Hello everyone, this is Nandhini, Assistant Professor, Department of Computer Science at Dr. SNS Rajlakshmi College of Arts and Science. So in this video, we are going to discuss about the tracking methods in AR. So let's discuss. The tracking methods is nothing but to determine the position and orientation of virtual objects within a real world environment, and it should be accurately. So these tracking methods are essential for creating the realistic and interactive AR experience. So here I mentioned the common tracking methods. So there are marker based tracking, markerless tracking, depth sensing, inertial sensors, visual odometry, and sensor fusion, cloud based tracking. So let's discuss one by one. So the first one is marker based tracking. So in this tracking, the important type is fiducial markers. So this methods use the physical markers with known as patterns like QR codes or black and white symbols. So the cameras are sensors to detect and track these markers to determine the pose, like a position and orientation of the virtual objects. So the marker based tracking provides a precise and robust tracking, but it requires the markers in the environment. And the second common type is markerless tracking. In this markerless tracking, the feature based tracking, it is a type of markerless tracking. So instead of markers, we can use the feature based tracking, and this tracking realize and distinguish the features in the real world, such as corners, edges, texture. So the computer vision algorithms identify the track these features to estimate the pose of virtual objects. So it does not require the markers, but it depends on the presence of sufficient unique features. And the next type is SLAM, which is nothing but simultaneous localization and mapping. So the SLAM combines the real-time mapping of the environment with tracking the device pose. So it is used in AR to build a map of the surroundings while simultaneously tracking the device position within the map. So the SLAM is common in the mobile app and AR headsets. So and the next method is depth sensing. So it is classified into three types. There are structured light, time of flight, and lidar. So the structured light is nothing but the depth sensing cameras project a pattern of light onto the scene and measure how it deforms on surface. So this data it is used to generate a depth map, and which helps in tracking and occlusion handling. The time of flight is called as a TOF. So it measures the time taken by light to bounce of objects in the environment. So this information is used to calculate the depth and improve tracking accuracy. And the next method is lidar. So the lidar is nothing but light detection and ranging. So the lidar sensors emit laser beams and measure their reflections. So they provide highly accurate depth data and making them suitable for the precise tracking, environment and mapping. And the next type is inertial sensor. So the accelerometers and gyroscopes. So the mobile devices and AR headsets often incorporate these accelerometers and gyroscopes to measure the acceleration and the angular velocity. So they are respectively these sensors helps to track the device orientations and movements over time. And the next type is visual odometry. So the visual odometry methods track the movements of distinct visual features in the sequentially camera frames and to estimate the camera's motion and position. So it is commonly used in SLAM system. And the next type is sensor fusion. It is combining multiple tracking methods and sensors such as visual tracking, inertial sensors and depth sensing. So we can improve the tracking accuracy and robustness. So the sensor fusion techniques use algorithms to integrate the data from multiple sources. So next last tracking method is cloud based tracking. So some AR applications use cloud based tracking, where the heavy processing and tracking calculations are of faded to clouds servers. So this approach can enable the AR experience on less powerful devices. So these are the types of tracking methods, and this is the assessment. These are the reference. Thank you.